We are going to write an equation for a line perpendicular to the line y equal 2x plus 3 and passing through the point -2, -4. Now, I find that students often have trouble with this type of problem. There's a lot going on. So let's take a look at a picture first before we actually get into the actual algebra work. Using Desmos, I can graph a line y equal 2x plus 3, denoted red below, and a point -2, -4, denoted in blue below. And what we're trying to do in this problem is we are looking for a line that is perpendicular to 2x plus 3, but passes through the point -2, -4. Specifically, let me look again. -2, -4 is right here, and I want to draw a line through this point that is perpendicular to y equal 2x plus 3. What does it mean to be perpendicular? Well, perpendicular, one of the symbols is an upside down T. It means the two lines meet at right angles. So let's draw a line that is perpendicular to the red line, but passes through that blue point. Now, this is just an eyeball sketch. This is not 100% accurate, but it's just to get an idea that we are looking for a line that is perpendicular to the red line, but passes through the blue point. Specifically, we are looking to write the equation of that line, y equals mx plus b, something. We don't know what it is, and our job is to figure out what is m and what is b. Or in other words, our job is to write the equation for the line. Now, different people use different methods for writing equations for lines, but one of my favorite formulas for writing equations for lines is what we call the point-slope formula. Y minus y1 equals m times x minus x1, and that should look kind of familiar to you. This is the one I like to use. This point-slope formula is very simple. You need two objects. You need a slope to use this formula, and you need a point, x1, y1. Now, the way our problem is set up, we have a point already. -2, -4 is actually our point. So we already have our x1 and y1 values. The only thing missing to finish this equation would be the slope. And that's where the first part comes in. Perpendicular to this line. That's where we're going to get the slope from. So let's get started doing that. How do we find the slope of a line? Well, if we're given a line, let's see, hang on, so let's write down slope. So we are going to find the slope. That's our job. And what do we know? We have a red line, y equal 2x plus 3. And what do we know about this red line? What is the slope for this red line? Well, the slope for this line is simply the coefficient on x, because we're already in y equal mx plus b, or slope-intercept form. So my slope for the red line is 2. Since my black line, the one I'm trying to get, is perpendicular to that line, that means I want a slope that's perpendicular to the original red line. And what do we do to get a perpendicular slope? We take the negative reciprocal of a given slope. So if our original slope is 2, I can also think of that as 2 over 1. And if I take the negative reciprocal, that means I flip it over and I make it negative. So that means my slope that I'm looking for on the black line is actually -1/2. I have all my pieces. Let me circle them in green, add some color here. So I now have the slope of this line right here. It's -1/2. And I also have a point on the line, x1, y1, -2, -4. So now I can go about writing the equation for this black line. Here we go. So I have y, so actually slow down, Tina, slow down. So now I'm going to write the equation. I'm going to kind of keep it organized if I can here. So we're going to write the equation. So I have y minus y1, which is negative 4, equals our slope, which is negative 1/2, times x minus x1, which is negative 2. That's it. That's going to be the equation for this line. But we want to clean it up a little bit and write it in y equal mx plus b form. So on the left side, I have y plus 4 equals, on the right side, let's just take a look at that. The double negative, negative is a positive, right? And we're going to have to distribute a fraction. That's okay. Not so fun for students often, but that's okay. We're going to do it anyways. Here we go. We're distributing this fraction through. So we've got y plus 4 equals negative 1/2 x plus, and I'm going to write it out here, negative 1/2 times 2, which is 2 over 1. It's one way to look at the fractions. When you multiply fractions, remember you multiply across numerators, and then we multiply across denominators and cancel. So off to the side here, I'll just do a little scratch work here. I'm doing this out just because this tends to be a spot where students get confused. So we're just going to do it out here. On top, I have negative 2. Negative 1 times 2 is negative 2. And on the bottom, I have 2 times 1, which is 2. And so that's actually just negative 1, right? That number is just negative 1. So let me write what I have. I have y plus 4 equals negative 1/2 x minus 1. And one more step to put it in y equal mx plus b form, or slope-intercept form. And that would be I need to subtract 4 from both sides. So we're going to subtract 4 from the left and from the right. And that's going to give us y equals negative 1/2 x minus 5. This is the slope-intercept form of the equation that passes through the point negative 2, negative 4, and is perpendicular to y equal 2x plus 3. And let's just look at our picture and see if it doesn't make sense. Y equals negative 1/2 x plus 5. That's what I say this line is. Well, what do I know about that? The slope is negative 1/2. That means I take any point and move down 1 and over 2. And sure enough, if I go down 1 and over 2, I wind up on the line. And better yet, check this out. The y-intercept is supposed to be negative 5. I miscopied when I brought it over here, right? Negative 5. And sure enough, look, that's exactly where I hit on the y-axis. This line is the one I graphed. This is the line that I'm looking for. Not too bad when you put it all together. Good luck working these problems. If you have any questions, let me know.